Hello, hi everybody. I am Michel Durr, representing Leti, a research institute from France, here at IMS 2017. Okay? When it goes to innovative RF or millimeter wave design, as we deal in Leti, okay, you have to manage what I call design iteration to get good results. Okay? One of the challenge is how you manage this iteration, and how you will be able to fix the bug or implement the improvements to be sure that on next revision you will have the expected results. Okay. What I will talk you about today is some advice and simple methodology to improve this process. First, I must say that when we talk about debug, it's like an all-day battle against the natural human behavior, and sometimes also against the management, okay? Just to illustrate that, some simple facts, okay? Naturally, you will focus on what is working on the chip and not taking time to analyze what is not working and how to fix your bugs. The second thing is, okay, maybe you may concentrate or be worried about who has done this bug that is observed, okay? And the other thing is, when you have a bug, natural behavior is just to implement very quickly a solution, rather than taking time to check if you have the right root cause and analyze in detail what happens. I think when you go to debug, you really have to change the mindset. The only thing that really matters is to implement, to get the list of all the bugs and to be sure that you will fix them. First phase is to find, the most critical phase here is focused about identification of the right root cause, okay? In this process you have two steps. The first is to find the IDs to get the right root cause. That's not something I will detail today because it will be too long. Just some advice about it. I think if a bug is tricky, you should work in a team. Don't work alone. You should consider the ideas of everybody and be very open-minded. Everybody, this means if this is a very experienced designer or junior, every idea can be interesting and you just should not remove it. What I recommend, what I will give as advice here is detail a methodology. When you have these different ideas about root causes, maybe you have 5 of them, is how you can do it to select the right one. What I would recommend is to do some kind of characterization of the bug. Characterization of the bug means you will detail very precisely what happens on your chip and also get what I would call the signatures. The signatures will mean what happens if you change, for instance, the voltage, the temperature, the frequency, or any parameter that could affect, like internal settings that could affect. And then you should observe what happens. Is it better, is it worse, or has this just no effect? All this will give you signatures. And the methodology to identify the right root cause is just based on the matching level of these different signatures between what you measure one side on the silicon and what you would expect, assuming that the root cause is a given one. Okay. And if you use this kind of methodology, you will see if you have a matching level that is above 50%, typically 75%, you will have a very good chance to have the good root cause, okay? You can't expect about 100% because if bugs are very tricky, you can't understand everything. On the other hand, if you have a low matching level under 50, typically 30 or something like that, I think you should look for other root causes because there is a high chance that you have not identified the right root cause. Okay, at the end, with this kind of methodology that is quite simple and efficient, you get rid of who has the best idea, okay? It's just a matter of selection. With this process, you will not have more than one root cause that may fit, okay? And it will not be dependent on who had the good idea. Is it a fellow? Is my idea better than this of my colleague? Okay. I have used this kind of methodology in several very difficult designs like this are presented here, and they get a very good match between what we observed on the next revision of silicon and the list of bugs with the matching level considered against the root cause identified. And we had every bug with 75% of matching or more. They were fixed on the next revision, okay? Most of the bugs with low levels were still present on the next revision. Only cases where we didn't totally succeed is the case of hidden bugs, okay? When you have a bug but is hidden by another, you cannot see it before you remove the first one, or some very complex multiple cause bugs, okay? So just I may conclude saying that debug is really something interesting for a designer with a real expertise and can be very exciting, even if it's not so much appreciated by management. Okay.